welcome to Basic Electrical Engineering. Today we'll be discussing Unit 5 Electrical Installations, Lecture 7 on 9th of April 2020. Let's see what is the syllabus related to this Unit 5. The topics in Unit 5 are the first one will be circuit breakers, wires and cables, batteries, earthing, energy consumption calculations, basic things, and power factor improvement. And what is a power factor, or what are the methods to improve? We'll discuss what is power factor, its importance and improvement. But before that, we'll see the introduction of, let's see the introduction, what a electrical installation actually means, or what are the different parts or different equipments that are present in an switchgear. In modern civilization, there is a great demand for electrical energy which can be used for residential, commercial and domestic appliances. As you know, electrical energy generated at a particular point reaches the appliances through different devices. There are many substations, many generating stations, there are many equipments that are present, so you have to know that these electrical energy that's generated is passing through so many things. So in this, there can be some normal and abnormal conditions of operation of the devices. Hence, it is desirable to protect the power system from these faults. Node switchgear is a component or a device which consists of switching and protecting devices to protect the generators, transmission lines, distribution lines from abnormal operations or abnormal conditions. What is a circuit breaker? Circuit breaker and a fuse are the devices which helps to isolate and protect the device at abnormal conditions. Then whenever the device is in abnormal condition, a circuit breaker or a fuse are used to isolate that particular device and protect it from the abnormal conditions. As we are seeing the effect of corona, we are isolating the people and saving them. In the same way, the elements or the equipments are isolated in order to uh, overcome these abnormal conditions and to get affected by the other uh, abnormal conditions occurring in the system. Now, battery is a device that plays a significant role in storing the electrical energy for future use. As you know, batteries are used for storing the energy and will use it for the future purpose. Tariff. What is a tariff? Tariff refers to an elementary calculation of electrical energy which the consumer is charged for utilizing the electrical energy. As you know, every month you'll get the electricity bill for the units that you are being used, because there is some expenditure that is spent on installation and generation of power. It has to be collected from the customers who are using it, either it can be domestic appliances or an industry applications. Based on that, tariff is nothing but the money that is imposed or the money that is collected. It is a charge that is, it is the customers being charged for their utilization. Now, in AC systems, power factor plays a major role in analyzing the system performance. So we'll see what is power factor. That is what is our topic for today. Now, what is the necessity of protection? Why do we need to protect the system? The operating voltage of an electrical power system varies from 415 to 4000 kilovolts or even higher sometimes. In different equipments used in electrical power systems, different equipments used are rotating machines, transformers, transmission lines, insulators, bus bars, cables and so on, which may be placed in open or closed conditions based on the requirement. Now, due to various reasons, all the equipment may undergo abnormal or faulty condition in their lifespan. There can be some disturbances in the circuit, there can be a short circuit, there can be a overcurrent, there are so many reasons. There can be natural disasters sometimes. A tree may fall on some transmission lines. Because of that, there may be a short circuit. So many conditions are there. They are faults. So the system may undergo into abnormal conditions because it has to carry some amount of current. It will carry a lot of amount of current. When there is a short circuit, a very high current flows and the system may get collapsed. Because of that, the total system collapses. Instead of that, what we'll do is we'll generally separate that particular part of the system where the fault is there, and we'll make the other system isolated from this system and protect that system from this, from the abnormality. So there some of the examples of faulty conditions are insulation failure in the cable. Sometimes the insulation may fail in the cable, uh, over voltage may be sometimes high, and undesirable heating in the transformer based on the construction, and because of the temperature there may be undesirable heating in the transformer, or weakening of insulation winding in the transformer. In general, the protection scheme is classified as primary protection and backup. Necessity of protection: in the primary protection is designed in such a way that the components of the power system are protected. In backup protection, in the secondary defense mechanism which comes into operation when the primary protection scheme fails. Whenever we want to isolate or protect the system, if the primary protection system fails, then we'll have some backup protection in the secondary defense mechanism. The different protective equipments or the devices that are used in the power system to safeguard the different equipments are circuit breakers, fuses, and protective relays. These are the three different equipments that are generally used in a substation or the switchgear system, that are used from protecting the. What is a switchgear? In electrical power system, switchgear refers to a device used for switching, controlling, and protecting the electrical circuits and components. It is used for switching, controlling, and protecting the electrical circuits or the components. What it is? In electrical process, refers to a device used for. It is a device that is used for all these operations. Now, essential features of a switchgear. What are the essential features that a switchgear must have? Complete reliability. If a fault occurs in any part of the power system, then the protective device should operate in such a way that the faulty sections get isolated from the other part of the power system. That is, it must be very reliable. Absolute discrimination. Clear and accurate discrimination between the faulty section and healthy section is required. If there is a fault on one section, let's say to a particular point there are 10 wires that are connected. Let's say there is a fault in the fourth wire that is coming to connected to that point, and if the switch gear isolates the fifth one in order to protect the other connected wires, it, it is there is no meaning in that, because the fault is on the fourth, it has isolated fifth. So it must have clear and accurate discrimination between the faulty section and the healthy section is required to isolate the faulty section. Now, essential features of a switchgear. Quick operation. The time taken by the protective devices to isolate the faulty section must be minimum, so that the other parts of the system do not get damaged. If there is any fault on the system, and if it's taking so much of time to isolate that system, then the other parts of the system or the protection devices may get damaged. So it must quickly operate and isolate that particular faulty system from the healthy system. Provision for manual control. Even if the protective devices can be made automatic, there should be a provision for manual control to carry out the necessary operations when the automatic control fails. Most of the times these devices are automated. They work automatically. If they find any fault, they are set such that if there is this much amount of voltage, if the voltage crosses this limit or the current crosses this limit, it should automatically isolate that system or disconnect that system from the rest of the system. And sometimes if that fails, we should also have some equipment to manually isolate it from the healthy sections. What are the components of a switchgear? The basic components of a switchgear are switch. The first thing is the switch. The device which is used to open or close an electrical circuit in most convenient way is called as a switch. It can be operated at any condition of the circuit. The main disadvantage of switch is that it cannot interrupt the current occurring due to faulty condition. Next, fuse. A simple protective device used to protect the cables and electrical equipment under overload and short circuit conditions is called as the. What are the components of the switchgear? The next third component is protective relay. In the power system, A device which continuously monitors the electrical quantities like current and voltage to sense the faulty conditions is called as the protective relay. The main function of the protective relays is to send the information about the faulty condition to the circuit breaker. A circuit breaker is a switching device which can be used to make or break a circuit manually or automatically or with the help of remote control under different conditions, that is normal and faulty conditions is known as a circuit breaker. So circuit breaker is basically a device which can be used to break or make a circuit manually with the help of remote control or manually anything. It just breaks the circuit if there is any faulty section, and after the fault is cleared it automatically makes it. Next, what is power factor? That was what is our topic for today. That is what is our topic for today. The ratio of active power measured in kilowatts to the apparent power measured in kilovolt ampere is defined as the power. That is what we have seen in AC analysis. The most economical value of power factor lies between 0.9 and 0.95, 0.90 and 0.95. In the power factor does not depend on the magnitude of voltage or current. The power factor of a circuit can be lagging, leading or unity. As you know, what are the causes of low power factor? If the power factor is low, then the active power and the apparent power are not approximately equal, and there is more of reactive power, and the energy that is generated is not much being utilized. So it is nothing but the low power factor. You have to make the power factor approximately equal to 1 to utilize the complete generated power and reduce the difference between the P and S. Next, single phase and three phase induction motors is the cause of low power factor, one reason. And other inductive equipments which cause low power factors are transformers, generator, arc lamps, electrical furnaces. These are the causes of low power factor. Next, the other one is existence of harmonic current reduces the power factor. Harmonic currents are nothing but there are sometimes there is a disturbances in the system which makes this current produce and there is some fluctuations in the current, they are harmonic currents reduce. Next, imbalance in the power system due to improper wiring or electrical accident, load variation in the power system. Now, effects of low power factor. What happens if the power factor is low? Current drawn by the circuit will be high, copper losses in the equipment will be high, and hence the efficiency of the equipment decreases. The current is high, copper losses will be high, and the efficiency will get reduced. The equipment gets overheated due to the copper losses, which in turn increases the stress on the insulation of the cable and makes it weak. That means because of this copper loss, the insulation of the cables get weak. As the current drawn by the circuit increases, the size of the equipment will be increases. That is, if the current required is more, you need to design in such a way that the size of the equipment has to be more. This leads to decrease in the active power, which results in uneconomic operation of the equipment. Next, what are the methods to improve power factor? Now, adjusting the power factor of a system closer to unity using some equipment is known as power factor improvement. What is power factor improvement? Adjusting the power factor of a system closer to unity. Power factor of a system closer to unity using some equipment is known as power factor improvement. Now, power factor improvement or correction reduces the apparent power consumed by the load, and hence current drawn by the load will decrease. Power factor correction is the injection of reactive power into the circuit to neutralize the effect of lagging current. Now, static capacitors, synchronous condensers are used to improve power factor. These are some of the devices that are used to improve power factor. What are they? Static capacitors, synchronous. Using static capacitors, they are used as devices to improve or correct power factor of the system. In three-phase system, the capacitors arranged in delta or star connection are used to improve the power factor, as you can see in the circuits. Delta connected capacitor bank, delta connected capacitor bank, star connected capacitor bank. These are connected to improve the power factor. The second method, what are the advantages of this static capacitor? Simplest method of the power factor improvement or correction. Maintenance required is very less in this method, And what are the disadvantages of this static capacitor? Lifespan of the capacitor is very short. It gets easily damaged due to over voltages. These are some of the advantages and disadvantages of the static capacitors method of power factor improvement. Now, applications of static capacitors. Capacitors in the range of few hundred kilovolt ampere reactive are used in industrial distribution circuits. Capacitors of 500 to 3000 kVAR are small distributions. Now, this is the end of the lecture 7. Thank you.